We have already discussed about 3 basic logic gates. Actually, this is there in O levels also. So the first gate is AND gate, second gate is OR gate, and third gate is NOT gate. So can you just remind the specialty of these gates? Yes. So AND gate, the specialty is like if you, so let me go and remind these things because this is very important to remember these features. That's why I'm again and again I'm just reminding these things. And you can remember the first logic gate that we have discussed. Just wait. The first logic gate that we have discussed is OR gate, right? OR gate, the specialty of OR gate is, so a OR gate is something like this. So it's similar to this. This is not OR gate, right? මේ OR gate එක නෙවෙයිනේ. OR gate එකට අදාළව මම නිකන් ඇඳපු circuit එකක්. And you saw that the specialty of OR gate නැත්නම් අපි හිතමු මේ විදියට. There's a water tank and there are 2 taps parallelly connected to this water tank. මේකෙන් වතුර ගන්න නම් එක tap එකක් ඇරියොත් ඇතියි. මේ පැත්තෙන් වතුර එනවා නැත්නම් මේ පැත්තෙන් වතුර එනවා. දෙකම ඇරියත් වතුර එනවා. වතුරෙන් නැති එකම වෙලාව. The only time that so water is not dispatching, the only time is when both switches are off. දෙකම off නම් විතරයි වතුර එන්නේ නැත්තේ. ඒ වගේම තමයි මෙතන. Switch දෙකම off නම් විතරයි මේ bulb එක පත් වෙන්නේ නැත්තේ. So here, if both switches are open or switch off, the bulb will not turn on. So the OR gate specialty is this. You have A input and B input both. So when you have input A and input B both, right? When you have input A and input B both, if both inputs are 0, then output is 0. That is the specialty of OR gate. Both are 0, then output is 0 always. Otherwise, it's 1. It's 1 all otherwise, right? Because if you switch off this one, still you get 1. If you switch off this one, still you get the power and bulb will switch on. And if you switch off both, or if you close both, again the bulb will work. So similar to that, this water and tap thing, if you turn, if you like on this, or if you open this gate, water will come. Open the second gate, again water will come. Open both gates, again water will come. But if you close both gates, or if you close both these valves, then water will not come. So the only occurrence is if all are 0, that is 0. That is, so we learned the specialty of OR gate. If all inputs are 0, then the output is 0. If all inputs are 0, then the output is 0, and that is OR gate. And we also learn about AND gate. So that is something like this, A and B. Here, if both valves are open only, you can take the water. This is a water tank. If both valves are open only, you can take water. Here also, if you switch off both valves only, if you switch off both only, or sorry, if you switch on both, or if you close both switches only, the bulb will work. So here you can see the completion of the circuit. So it is the other way. If both inputs are 1, then output is 1. 1 means the on state, or maybe you can say valve open state. So whatever the state, a working state. 2 working states, maybe if both inputs are 1, then only the output is 1. That is about the AND gate. The third one, NOT gate, we learn about this as well. NOT gate will simply invert. 0 will be inverted to 1, 1 will be inverted to 0, and this is how you represent. Today we are going to learn about these representations, right? Boolean algebra representations, as well as we are going to learn about one more gate, that is this XOR gate. Okay, please write down the heading, exclusive OR gate or XOR gate. So this gate is special because this can be used to do a lot of things, including in future, we will be using for security of like designing secure circuits or design maybe applying security in IT. This gate is really useful. And this gate is also useful for calculations like adding, multiplication, adding. This gate is really a good solution. So the input combination is also taken into consideration when consider about the output. Inputs make it balanna ඕන අර විදියට. Here actually there's a specialty. So this will output 1 if number of ones in input are odd. So that is bit odd නේද? එකේව ගාන number of ones in inputs out. ඒ කියන්නේ මේ තියෙන input වල තියෙන එකේව ගාන odd නම් here එකේව එකක්වත් නැහැ inputs වල. Here in the second one you can see one is odd. Here again one input is there, that is odd. If it is odd, this will output 1. And if it is even, here there are 2 inputs. So if it is even, it will output 0. This is odd even gate, or this is called XOR gate. Please write down the note XOR gate. If you are only writing in English medium, that is okay. So write in English medium, XOR gate or exclusive OR gate. The speciality is this. Let me highlight. And this is the symbol. This is the symbol. Same O, but circle around the O symbol. O symbol එක වටේට පොඩි circle එකක් තියෙනවා. ඒක තමයි XOR එක. එතකොට මේ තියෙන්නේ truth table එක. So this is the truth table. You have to draw the circuit and truth table, all 3 things. So please do that. And then I'll give you another work, small thing to try. So let's say you have 3 things, A, B, C, 3 inputs, A, B, and C, and then try to figure out the output A XOR B XOR C. Try to figure out that output. What is A XOR B XOR C? By drawing a truth table, right? You have to draw a truth table, and by doing that, you can figure out the output. So this is easy. Consider about the statement that I have given. මම කියපු statement එක හරියටම ඔළුවට දාගත්තා නම් මේක හරිම ලේසි. If number of ones in the inputs are odd, then it will output 1. Number of ones in the inputs are odd. Inputs වල තියෙන inputs are A, B නේ මෙතන. මෙතනදී නම් A, B, C තුනක් තියෙනවා. එතකොට ඒකේ තියෙන 1 ගාන odd නම් then it will output 1. Okay, can you try this one also? Just give a try to do this one also. Then I'll show you the answer, but just try whether you can do it or not. Just give a try. Okay, if you have any difficult point, you can ask now. Enuka, did you understand this?
Yeah.
Enuka, I cannot hear you. Enuka, did you understand? Okay. Imesh?
Yes, sir.
I hope, right? Okay. So please draw this and also do this and let me know, then I can show you the answer. මම answer එක පෙන්නන්නම්. But before that, you try to do this alone. තනියෙන් කරන්න try එකක් දෙන්නකෝ. බැරි වුණොත් මම උත්තරේ පෙන්නන්න බය වෙන්න එපා බලමු. මොකද යන්නේ කියලා. Right, let's see your answers and check whether your answer is matching with this. If not, please let me know. So then I can explain again and help you understand the concept of XOR gate. This is simple. Here, see. So this is what I have explained. Okay, sorry. Right. So this is what I want to show you. A, B, C are the inputs. Make it right, Pute. I think you have finished drawing this, right? Okay, if not, please tell me. Here, this is A, B, C. 3 inputs are there. Then, so the 3 inputs means 2 to the power 3 combinations. 2 to the power 3 means 8. So you can write 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Then 0, 0, 1, 1, 0, 0, 1, 1. Then 4 zeros, 4 ones. And these are the combinations. 0, 0, it's 0. 0, 0, 1, you have 1. Therefore, it's 1. 0, 1, 0, you have 1. Therefore, it's 1. 0, 1, 1. You have 2 ones. Even. Even means 0. Here, 1, 0, 0. It is odd. So you have 1, 0, 0. Only 1 is there. So it is odd. So, and 1, 0, 1, you have 2 ones. 2 ones means 0. 1, 1, 0 is 1, 1, 0 is 0 because you have 2 ones. 1, 1, 1, 3 ones. 3 ones means odd. And you have 1 there. So this is the result. And XNOR is reverse of this. XNOR is reverse of XOR gate. You can draw and try XNOR also. And let me show this, then you can understand, show this practically using our virtual platform, that is logic.ly/demo. Okay, let me send you the link. You can try this link in your mobile or in your computer. Try kala balana puluwan mekema. Hari. Let's take XOR gate, meaning XOR gate එක. Let's increase this to 3 inputs. Let's connect the switches to wires. XOR gate එකක් අරගෙන I'm taking 3 toggle switches and I've connected wires and a bulb to check this, how it's working. 1, it's 1. This one is 1, again 1. This one is 1, again 1. So you can see the bulb. And if both are 1, so this is even. Even means it's 0. If all 3 are 1, then odd again. Because it's odd. These 2, even. And what about this 2? Again, even. Right? This is the odd even behavior of this gate. Okay, now try to use this. I will try to use this and create some creative circuit related to adding numbers. Okay, so you can write down this, and also please draw the XNOR gate, that is XOR gate with a NOT gate. XOR gate, then NOT. You write this as A XOR B XOR C, everything NOT. And just draw this, and after that please write the heading XNOR gate and show this XNOR, and also the Boolean algebra notation. This is called Boolean algebra notation. How we write this. And also you can draw the truth table to finish. So truth table is simply reverse of the previous one. So let's, okay, reverse of the previous one. You can just draw the circuit and draw these lines, everything, the XNOR symbol notation, then the output. Okay, now, so let's try to do something innovative. Okay, so while drawing this, please try for this example. I'm taking a new one and just put it aside. So let's say you are given a task to add 2 numbers. Let's say you are given a task to add 2 binary numbers. And can you tell me, or just think, 0 plus 1, 0 plus 0 is 0. If you add 0 plus 1, this is addition, right? It is 1. 1 plus 0 is also 1. What about 1 plus 1? 1 plus 1 is 2. But you don't have 2 in binary, therefore you write as 1, 0 in binary. So this is how the addition happens. So, see, addition happens. This is the base. Binary addition. When you add binary numbers or 1, 0 numbers, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 2. This is addition. This is not XOR, this is not some other gate, this is addition. Right? If you write this as a table, so let's create a table. Right. So I'm going to create a table. So the first number, second number, third number, as well as the first number, second number, third number, and sorry, I have only 2 numbers. Then the addition and the remainder. Okay, it has only 4 cells. I hope you have finished drawing this. If not, please let me know. Make andinawada tama, nata finish. Come on, tell me yes or no. Have you finished?
Yes.
Seems no. Okay, yes. Right. If not, please take a screenshot and do this. Right? Okay, now I think it's enough. So let's move to the today's topic. We are going to discuss about one more combinational logic gate. Combinational logic gate means, what is a combinational logic gate? Combinational logic. Creating logic circuits using basic gates. Creating logic circuits using basic gates. What are the basic gates? And, or, not, and now we learn XOR. Creating logic circuits using basic gates and current inputs will decide the current output. So in the combinational logic gates, the current inputs will be the decider for current output. Then input එක අනුව තමයි then output එක හැදෙන්නේ. Okay, that is the main heading. Combinational logic gates, creating logic circuits using basic gates, and the current inputs will decide the current output. And within bracket you can say no memory. So that's simple. You don't memorize the previous inputs because there's a category still we have not learned. There's a category of logic gates which will memorize the previous. මතක තියාගන්න පුළුවන් જાතිය logic gates උත් තියෙනවා. ඒකයි මම මෙහෙම විශේෂයෙන්ම කිව්වේ. දැන් මේවට මතක තියාගන්න බෑ. Combinational logic circuits වලට මතක තියාගන්න බෑ. Based on the current inputs, current output will be there. Current input වෙනස් කරොත් output එක වෙනස් වෙනවා. කලින් මොනවද දුන්නේ ඒව මතක නැහැ. Then input අනුව then output හැදෙනවා. Okay, under that the binary addition. We are going to try for binary addition. Let's say let's assume A and B are inputs, binary inputs, and P and Q are outputs represent remainder and sum respectively. Right? Remainder and sum respectively. Remainder means the balance. After addition, is there any balance? And Q is basically remainder is P, right? So let's say remainder is P. P is the remainder. And sum is Q. Sum is the addition. That is Q. The remainder is P and sum is Q. Okay, let's create a circuit for this. I'll give you the task. So please try to create. You have A, B out inputs. If there are two inputs, how many outputs? Inputs දෙකයි නම් outputs කීයක් එනවද පුතේ? How many outputs? Yes. If there are two inputs, how many outputs? Yes. If there are two inputs, how many outputs? How many combinations? Sorry. How many combinations? This I already discussed, right? So no one is telling this. Are you like kind of struggling here? This question. So let's say if you have only one input, එක input එකක් තිබ්බොත් මේකට දෙන්න පුළුවන් එක bit එකක් නම් input එකක් තියෙන්නේ මේ bit එකට ලැබෙන්න පුළුවන් එක්ක 1 or 0 or 1. Okay, let's say there are two bits. මේ bits දෙකට වෙන්න පුළුවන් අගයන් තමයි this can be double zero, both can be 0. One can be 1, the second one can be 1, or the first one can be 1, or both can be 1. So So these are the possible combinations. Let's say there are 3 bits. So what are the combinations? All 3 can be 0. First 2 1, the last one 0. First is 0, second one 1, the last one is 0. First one 1 0, second one and last one 1. Then 1 0 0, 1 0 1, 1 1 0, 1 1 1. How many combinations? Yes, how many combinations? Count and tell me. If 3 inputs, how many combinations?
8.
8 combinations. Okay, if there are 3, anyone can answer, right? If 1 input, there will be 0 and 1, only 2 combinations. 2 inputs, 4 combinations. 3 inputs, 8 combinations. What happens if there are 4 inputs? How many combinations?
16.
16 combination, yes. Here, 1 input will give 2 combinations. And 2 inputs will give you, so if you don't know, please write down, right? 2 inputs will give you 4 combinations. 4 means actually speaking, 2 to the power 2. That is 4, right? So this is how you calculate. දෙකේ දෙවනි බලයක්. 2 input කියලා කියන්නේ දෙකේ දෙවනි බලයක්. 4 combinations. Then 3 inputs will give you 2 to the power 3. 2 to the power 3 is 8 combinations. දෙකේ තුන්වෙනි බලය. දෙවරක් දෙක. 2 into 2 into 2. දෙක වැඩි කිරීම දෙක වැඩි කිරීම දෙක. දෙකේ තුන්වෙනි බලය නැත්නම් 8 combinations. 2 inputs will give you 8 combinations. If there are, 3 inputs will give you 8 combinations. If there are 4 inputs, how many combinations? 16 combinations. 4 inputs, 16. 5 inputs. Yes, 5 inputs.
32.
32. 6 inputs. Only Enoch is answering. Others?
64.
6 inputs. Yeah, 64. 7 inputs.
128.
128. It always doubles, right? තේරුණාද අනිත් අයට? Others understood or not? If yes, please raise your hand. If you understand, please raise your hand. Okay. Only one raised the hand. Others? Okay, 2. I think 2 can understand. Enoch also understood. Imesh? Raising hand is like, okay. කියලා අතුස්ස ගන්න ඕනනේ. මෙතන තියෙනවා more වල තියෙනවා. How to raise your hand? It's in more. Sorry, annotate. In annotate, you can just give you the feedback. Okay. Then, so you have 2 input, 4 combinations. Let's write the 4 combinations. ඒක ලියනකොටත් අපිට ලේසි විදියක් තියෙනවානේ. 4 combinations can be written by interchanging, toggling the value 0 1 0 1. ඒක තමයි ලේසිම. ඊට පස්සේ ඒක ඩබල් කරලා toggle කරන්න. 0 0 1 1. binary වල හැටි. තුනක් තිබ්බනම් 0 1 8ක් ලියනවා 0 1 0 1 0 1 0 1 කියලා. then you double and toggle. 0 0 1 1 0 0 double. then you again double. 4 zeros 4 ones. Okay, I'll give you more inputs and see. බලමු ඉස්සරහට. Okay, now you have P and Q. P is the remainder and Q is the sum. Okay, can you tell me the value? What is P? 0 plus 0. What is the remainder? What is the sum? Sum is 0. 0 plus 0. Sum කියන්නේ එකතුව. Sum is 0. So what is the remainder? Imesh, what is the remainder? Imesh, are you there in the class? Imesh, I think there's some error, it seems. Okay. Okay, anyway, 0 plus 0 is 0. Okay, then anyone else, can you tell me the remainder?
0.
Yes, remainder is also 0. 0 plus 1. Sum is 1. එකතු 1යි. ඉතිරිය බිඳුවයි. බිඳුවයි 1යි එකතු කරාම එකතු 1යි ඉතිරිය බිඳුවයි. 1යි බිඳුවයි එකතු කරාම ඒත් එකතු 1යි ඉතිරිය බිඳුවයි. 1යි 1යි 1 plus 1. 1යි 1යි දෙකෙන් බිඳුවයි එකක් ඉතිරි. අපි එහෙම තමයි ලියන්නේ. 1යි 1යි 2යි එන්නේ උත්තරේ. එක අපි ලියන්නේ 1යි 1යි දෙකෙන් බිඳුවයි එකක් ඉතිරි. 1 plus 1 is 0, remainder 1. 1 plus 1 is, the sum is 0 and remainder 1. This is how we write. And these two are output. Let me color. So these two are outputs. These two are outputs and these two are inputs. Now try to draw the circuit to represent this scenario. Okay, please write everything, the combinational logic gates, binary addition. Then also, if you don't know how to get the combinations based on the inputs, combinations based on the inputs. Combinations based on the inputs. Please write that. Then this is the truth table for binary addition, showing 2 inputs and 2 outputs. That is sum and remainder. Okay, please write down this and draw the truth table and also try to create, draw the truth table and also try to draw the circuit. Circuit එකත් අඳින්න try එකක් දෙන්න බලන්න. If you have any issue, any difficulty, you can chat, you can send me a message, maybe a personal message, don't mind, or to the message to the group, or you can talk. Anything is okay. කතා කරන්න බය වෙන්න එපා. කතා කරා කියලා කවුරුත් සල්ලි ගන්න නැහැ වැඩිපුර. අනිත් එක ඔයගොල්ලෝ කතා කරනවා නම් ඔයගොල්ලන්ට තමයි ඒක උදව්වක් වෙන්නේ. ප්‍රශ්න නිරාකරණය කරගන්න පුළුවන් කතා කරාම නේද? So don't be afraid. Okay. Okay, just think like this. So just think. Only consider about this one P. P විතරක් තිබ්බොත් මොකක්ද වෙන්නේ? Just forget Q, right? Forget Q and think about P. P, if P is output, so this will output 1 when these inputs are 1. So what is this gate? What should be P? P මොකක් වෙන්න ඇතිද? P එකේ output එක 1 වෙන්නේ මේ දෙන්නම 1 වුණාම. දෙන්නම 1 වුණාම 1 දෙන්නේ කවුද? What is the gate? You know it, පුතේ. දැන් මම ඒක discuss කරලත් පටන් ගත්තේ. If both are 1, which gate is output 1? Which gate will output 1? දෙකම එක දෙන්නේ AND gate එක. So here P is AND gate. So what you can do is you can employ AND gate here. එහෙමනම් ඒ P වෙනුවට P ව ගන්න තැනට AND gate දාන්න පුළුවන්. P AND gate එකක් අඳිමු. Using this. හරි. වෙන P ව ගන්න පුළුවන් මම පොඩක් පුංචි කරන්න. AND gate එකක් පාවිච්චි කරා නම් P ව ගන්න පුළුවන්. Let me draw the wires. Draw එකෙන් මම අතින් අඳින්නකෝ මගේ ඇඳිලි නම් කැතයි. මේ විදියට එන එක.